Hi everyone, welcome back to our YouTube channel City Education. In our previous video, we have seen the foundation of this insertion sort algorithm and on what approach this algorithm works on. In this video, we are gonna see the example, and from this example we'll understand how this algorithm actually works. In our coming videos, we are going to drive the algorithm using this example and gonna drive other parameters like time complexity, space complexity, and we are gonna conclude with several examples for the practices. So if you're new to this channel, please do like, share, and subscribe, and we'll get started with that. Let me take an example. Let's say a small example. I have an array with elements 7, 4, 5, and 2. Now I have to apply insertion sort algorithm to this. So what we do, we basically get started with the second element of an array. And what we do, we basically compare to its left element. We compare, we will get started with the second element and we are going to compare with the left element. Let's say I call this as current element or a key element. Okay, let me call it key element. Okay, not current. If my key element is less than the left element, I'm gonna again check. So as of now, I only have this 7 here. For example, I'll see in the iteration, right? So let me write that one. Okay. So is this correct? Yes. If key element is less than left element, then we are going to shift its position. So its position will be 4 here, 7 here, 5 and 2 will remain same. We are not going to change these things. So basically, if you have seen my previous video where we were talking about decrease and conquer, what we do, we considered this as sorted. This is what our assumption, initial assumption, and we consider this as unsorted. So we're going to take each element from this and gonna put into the right position. It's also based on what you see, right? For example, if you are paying a cards, right? So you know that if this is 1, this is 2, and this is 5, and I have a card, let's say A. So you know that position of this A will be where? It will be here, right? Because these are sorted, this is not sorted, correct? So like this only we do. Now, when we are done with second, we are going to get started with this. We are going to say this is key element. Now we are going to check with the left element first. Immediate left. Is key less than the left element? Yes, that is true. Then I'm going to shift the position so 7 will come here. Then again, now there is one more element, right? So I'm going to check with this. Now here my key was again 5. Is it going to the one more left element? So here it fails. No. So you stop here. So 7 will come here, 5 will come here, and 4 will come here, and 2 remains same because it is not taken. That is iteration number 2. So our understanding, what you need to do, so whatever you need to check in the left, if it is less than, you keep going. If it is not less than, you stop there. But you need to compare. Correct? Now, let's take one more iteration, iteration 3. So now you have the third element. Oh, that is the unsorted, right? So you're going to compare this. So I'm taking as this key. So is key less than left element? Yes. See, 2 is less than 7. So 7 will come here. Is 2 less than 5? Yes. So key is less than left. That is true. So 5 will come here. Then again you are going to check, is 2 less than 4? Key element is less than left. True. So 4 will come here and then means the position of 2 lies here. So you will get the sorted array. You will get the sorted array. Okay. So how we can quickly do that? So this is, I have given you in detail how actually the algorithm traces out. So if you see number of comparison, so you made one comparison here, correct? In iteration 1, you made one more comparison here, correct? Now if you see, you made two comparison actually. When you says 5 is less than 7, correct? And you made this comparison. So 1, I'll name this comparison 2, 3, 4, then you made 5, and you made 6 comparison. The total number of comparison we made 6. Now one more important point to observe, if you have n elements, so here how many elements we had? We had 1, 2, 3, 4 elements. How many iterations we had? 3 iterations. So if we have n elements, we will have n minus 1 element. Sorry, iteration, my bad. Iterations. Are you getting it? Now, the problem is insertion sort is a simple algorithm and we are taking so much of time to, sort this. What is the quick way or quick hack to get it done? So I'll tell you a quick hack, which is my favorite, and I call this hack as slider window. What you do, you put a slider after second element and shift that slider again and again to the next element. For example, I will put a slider here. Now you sort, so you know the sorting, right? You know how to put in a sequence or how to put in ascending order. So whatever elements you have in the left of this slider, you sort it. So, so in first iteration, you sort this 7 and 4. So you will get 4, 7, and you keep other element like this. Now you slide this slider to the next position. So it will come here. Now you sort this again. So in second iteration, you will get 4, 5, 7 if you sort them, right? Now you put slider to the next position, that is here. Now you sort this. If you sort this, you will get 2, 4, 5, 7. So if you see, 4, 7, 5, 2 was the same sequence we got after first iteration, 4, 7, 5, 2. 4, 5, 7, 2, 4, 5, 7, 2, 2, 4, 5, 7, 2, 4, 5, 7. Are you getting it? So this is how we can work quickly on the insertion sort, but only problem is this is not actually how the algorithm works. I have told you the hack, right? The slider window. There is no concept of slider in the algorithm. It is on the basis of this comparison. Correct? It's based on the comparison. So in our next video, let's draft the algorithm based on these things which we have taken here in this example. After that, we are going to take some more example for your understanding and your practice. So if you like this video, please do like, share and subscribe. Thank you.